Where is Aubrey?
Okay, Aubrey, we're going to talk a little bit about 5-2, which is binomial probability. You need to write this guy down in the top because that's the formula that we're going to use. And here is my example. My kill rate for plants is 80%, and if I have 10 plants, I want to know the chances that 3 of them live, okay? Now, the thing that makes this hard is that we're trying to create a table, and I have 10 plants, right? And what could happen with those 10 plants is I could have 0 live, which means 10 die. I could have 1 live, which means 9 die. I could have 2 lives, which means 8 die. I could have 3 live, which means 7 die, right? I could have 4, 5, 6, 7, 8, 9, 10, right? Like this is what this table looks like. This table gets to be pretty hefty, like the more you get, right? Okay, but I could have that happen. I'm looking at finding the probability of exactly this happening, right? 3 live, 7 die. That's what I want to find. I want to find that probability exactly. Now, the thing that gets a little hairy here is that my kill rate is not 50-50 like it is with boys and girls and like it is with tossing coins, right? That's what we've dealt with before, our 50-50 rate. My kill rate is 80%, which is not 50-50. So we've got to take, that's another added element into it. But the nice thing is we have a nice formula that we're going to do, and this makes it easy, right? There are 3 big pieces to this formula that you are multiplying together. So first things first, we have to find NCR. Second thing, we have to multiply by P to the R. And third thing, we have to multiply by Q to the N minus R. So here we go. NCR. What is N in this case?
3. No. 10.
N is 10, right? And I'm choosing 3 of them to live. So N is 10, and I want 3 to be living, okay? Now, P and Q don't matter so much. Which one is which, right? P and Q have to do with the living and dying rate, right? So let's say P is 0.8 and Q is 0.2. If I flip those around, it's not that big of a deal because the exponents that go here just depend on which one goes in this spot, right? If 80% is my kill rate and I want to know that 3 of them live, how many are going to be killed?
7.
So is 7. So I want 7 to be the exponent on the 0.8. Does that make sense? And 2 is my live rate. So I want 3 to be the exponent there, right? Let me say that again.
Wait. N minus R, O would be 3.
Yep. N minus R is this exponent right here. N is 10. These 2 exponents, no matter what, should add up to be
10.
N, right? Or 10, whatever your N is, right? Okay, so it doesn't matter if I flip these 2 around. If 0.8 is my kill rate, the exponent should be how many I'm going to kill. 0.2 is my live rate. The exponent should be how many I want to live. Does that make sense? Okay, now, the kicker is typing this thing in. You can type this in all at one shot, and you don't even need to use parentheses. You can use times here if you want to, right? Okay, so do that really quick. Do you guys know where your C button is? Yes, you should, from last chapter, right? Okay, so type this in. Type in 10C3. If you want to hit enter, you can. After 10C3, I don't care. But do 10C3 times 0.8 to the 7th power times 0.2 to the 3rd power. Type that in, practice doing it. What is the chances that 3 of them are going to live?
0.201.
0.201. 0.201. Let me write that down. 0.201. I'll fill that in the table.
2%.
What?
20%.
How do you do your C? Your C button, I think, is on the main screen here. I don't know how to do it on this one. Menu. I don't know.
That's why you have to have
my old calculator.
I don't know where he went.
those things on red.
Exit.
I have everything I need white.
I accidentally found it earlier and I don't remember.
You did?
Yeah, well,
I don't know.
make a graph.
Program quit.
Graph.
Catalog. Is he under catalog? No, he's not under catalog.
Mommy, do you have your iPad?
I don't know. I'll look him up here in a little bit. Do you want a different calculator in the meantime?
Let me borrow your iPad.
Why? What'd you get?
Just need over here. That's all. Just need that.
Here you go. You want to try this one?
Don't be quick.
All right. Did you get 0.201? Yes. Yeah? Hopefully? Maybe? Okay. Now, what we could do is we could fill this whole table in, right? This guy would be the chances of 0 living. So this would be 10C0. P would be 0.8 because that's my kill rate. If I want 0 to live, then what's the exponent on the 0.8? 10, right? And 0.2 would be to the 0 power, right? And I could fill that in and figure out that probability. Then I switch it and it's 10C1, 0.8 to the 9th power, 0.2 to the 1st power, and I get that and I plug it in here. And what do all of those probabilities end up adding up to be? 100% or 1, right? Here is the kicker question. Are you ready? Which one of these numbers right here will end up being the highest? This is 20% right here.
Oh, wait, no.
Which one will end up being the highest? 2, because that exactly matches my kill rate, right? A 20/80, right? So 2 living. What is it? So this would probably be like 25%. I have no idea what it is, right? But that should end up being the highest probability out of all of them because that split, the 2/8 split, is the one that most like corresponds to my kill rate, right? What if my kill rate was 0.75? Then which one would be the highest? 2 and 3 would probably be equal, right? Does that make sense? Because my kill rate would be 2.5, right? 2.5, 7.5 split. That's my 0.75, right? So these two probabilities would end up being like the same or close to each other, right?
You have to add
Does that make sense?
them.
Yeah, yeah.
Kind of, sort of,
Yeah, kind of.
no.
They're not going to ask you 2.5 though. They're going to say, what's the chances of 3 happening or whatever, or 2 happening? Okay, good. Clear as mud? We're confused? Okay, let's fix it here in a second. All right, now, we have, in order to have a binomial, what's binomial mean? 2. We have to have 2 things happening. Heads, tails, boys, girls, kill, live. What if I want to do a binomial with rolling a dice?
You would roll
Odds, evens. Rolling a 5, not rolling a 5, right? I could even do that. 2 different options, okay? Binomial, 2 different options. We have a fixed number of trials. That's your n, right? N has to be equal to a set number, like 10 plants or whatever. The trials must be independent. That means that it's not like we're like not replacing a card, right? Where my second number is dependent on my first number, right? Okay, so they're independent. That usually is not a big deal. And then we have 2 categories. We either have a success or a failure. In my case, it was kill, live, and die, right? Or maybe it's even and odd, success and failure, right? Or maybe it's boy and girl, right? Okay, but we have a success, we have a failure. They're like opposites of each other, okay? The probability of success remains the same in all trials. So my kill rate's going to be 80% regardless of whether I'm talking about the first plant or the 9th plant, right? My kill rate's the same. All right, next. We have N we talked about. They have this formula written down here and they call, this is very confusing, not really. They call it X instead of R. I always call it R because that's what it looks like on your calculator. So don't let that confuse you. They call it X, I call it R, whatever. They mean the same thing. X and R are the same. Got it? That's the formula they give you on the second page. Woo! Let's do example 1. Okay? When an adult is randomly selected with replacement, there is an 85% probability that this person knows what Twitter is. Okay? So let's call that P. P is 85, and after the P, I'm going to put no Twitter so I can keep track of what I'm talking about. And now it's not even called Twitter anymore. They're going to have to revise this, right? Is it called like X or something? Yeah. Something silly. Okay.
Why?
0.8, I have no idea. 0.85 is the chance that I know Twitter. What is Q? 0.15, because those have to add up to be 100%. So either we know Twitter or we don't know Twitter. Don't tweet. Okay? All right, no Twitter, don't know Twitter. All right, suppose that we want to find the probability that exactly 3 of 5 randomly selected know what Twitter is. So what is N? 5. What is R? 3. They also call this X instead. Whatever. Okay. Does this result in a binomial probability? Yes, because we either have no Twitter or don't know Twitter. We have 2 choices. Yes. 2 choices. Either Twitter or not Twitter, right? That's binomial. Binomial means 2, okay? All right, if this procedure does result in a binomial distribution, I identify the values of N, X, P, and Q. We did that already. I'm going to go one better, and let's actually find what it is, right? Since we know the formula already. let's do the formula. P of X is the probability. We go 5C3. And then I'm going to put my P and my Q, and I'm going to figure out what probability it is. So 0.85 and 0.15. This is no Twitter. This is don't know Twitter, okay? I need to figure out the exponents. So I want to know exactly 3 of them know Twitter. So does the 3 go on the 0.85 or the 0.15? 0.85. Then what goes on the 0.15? 2. Do we see how that works?
Yep.
I can figure out which one goes where. Got it? Okay, practice typing that in. What's the chances that exactly 3 out of 5 know Twitter? What? 13.8%?
Yep.
Or 0.138, okay? Whichever one you decide. I think if we're filling out a table, go ahead and leave it as 0.138, okay? But if they're asking a random question and say, what's the probability, you can switch it to a percentage, okay? But if we're filling out the table, just leave it as a decimal. Yes, ma'am?
Where do we get the exponents again?
The exponents come from, I want to know, they say that. Suppose that we want to find the probability that exactly 3 of the 5 know what Twitter is, okay? So I know that my R is 3, but then we have to decide, does 3 go here or does 3 go here? 3 goes here because no Twitter is 0.85. And if 3 know Twitter and we have 5 total, that means 2 don't know Twitter, okay? Do we see how that works? Yeah? Okay, there you go. Let's do another one. We already did this one. Example 2 is what we just did, and we're good, right? Like we did example 2 in example 1. Sorry, I jumped the gun.
0.13.
So, see example 1. We already did that one. Sorry. Let's go example, gosh dang it. I don't know if they're going to be able to do this one. This is an overflow.
From,
Let's go example 4.
wait, what do you
We'll
mean
come back to example 3.
overflow?
My N and my R are so big, and this is the one where you have to use a computer on. So let's save example 3, and I'll do it with a computer. Because it's going to say overflow error in your calculator. I don't know.
Wait,
I don't know.
how would you do it on a computer versus on the calculator?
A computer will do it, and a calculator won't. You have to...
No, where do you go on your computer? You just can't just Google. Blah, blah,
Right,
blah, blah, blah.
right. There we have to go on to like I might just skip this altogether. There's a software that comes with this book that's called StatDisk. It's for like people who are actually do this as a job, and it will do big numbers like this.
Okay, cool.
But I'm not going to ask you to do one of those on your homework assignment.
Well, yeah.
So let's set this one up. Let's do example 3 and we'll set it up, but we will not calculate it because you're going to do an overflow error. There were 460 NFL football games decided in overtime, and 252 of them were won by the team that won the coin toss. Okay,
460 C252. Wait,
460 is what?
the N.
N. 252 is the
R.
R. Okay, and these are the winners of the game and the winner of the coin toss.
Equivalent to, wait, what? They don't do this for
Okay, so 252 times. What would be an even split of 460?
Oh,
230, right? 230 should win, 230 should lose, right? But what they're trying to figure out is if you win the coin toss, are you in overtime? If you win the coin toss in overtime, do you have a higher chance of winning the game?
Probably.
In an NFL game, in overtime. Because don't they just play until the first team scores?
Yeah.
So if you win the coin toss and you score, the other team doesn't even get an opportunity to have the ball. True? Right?
Yeah.
I don't know how it works. I think that's how it works.
If you score a touchdown, it's over. But
Right.
If you kick a field goal, then the other team has a chance.
Okay, good. Thank you for clarifying that. Anyway, right? So they're testing. They're trying to see if there is a higher chance of the winner winning if they win the coin toss. Right? That's like what we're debating here. Okay. All right. We can answer that question by finding the probability of 252 wins or more in 460 games, assuming that wins and losses are equally likely. So, if we do N, C, R, P to the R, Q to the N minus R. N is 460, C 252. What's P?
We don't know. Should we divide 460 by...
There's a P and a Q.
0.5.
P and a Q would be the chances of winning, chances of losing. And they're saying they're equal chances of winning and losing.
Oh,
right?
yeah, because it's a coin toss.
Not necessarily where they're talking about winning and losing. If you're in overtime, like the teams are going to be pretty well, like even anyway, and even would be 50-50, right? Whatever. So we got 252, and what's the other exponent? 208. 208. If we do that and you try to type that in your calculator, you get something that says overflow error,
Well,
right?
let's just try it. 460.
I think I tried it last time.
C 252.
Can I do it on my phone?
Oh, it does say overflow error.
Overflow error. Let's see what the book says the answer is. Yes.
Calculator looks like Josie.
Oh, is that your calculator, Jose?
Look for a calculator that looks like that.
Hold it up. And it's gray, though, not black? Let me see.
It's a Texas
Okay,
Instrument.
I will see. Okay.
Oh,
We
like
were
mine? I have one.
we were using
Yeah, yours is
calculators
like blue.
in my
right?
8th period class the other day. I'll see
You
if
and
they
Mackenzie
have
have
it.
the same
Because they
one.
might.
Yeah.
Does it look like this one?
I thought my
Yeah.
Somehow, and like it works.
I don't know.
I like my Texas Instruments.
Overtime rule.
I don't like mine. It's mine.
What?
Point. Here we go. Ready? They did it. You have to like use a stat disk is what it's called, like this thing. Otherwise, you get an overflow error. So it's possible to do, but your calculators won't do it. The chances of that happening is 0.0224. Okay. Why does that even mean anything to me? 2.24% chance. Of.
Very big chance.
That is the percent chance of that split happening exactly. Right? This is the probability that the 252 will win out of 460. Okay? That's the chances of that happening randomly by chance. So, the fact that it does happen, that split, means something else is significant. That means the coin toss is probably affecting the chances of win-loss. Does that make sense? Because this is a significant event, which means it's significantly rare for that split to happen, and the fact that that split did happen means that the coin toss is probably causing that win split to happen, right?
Yes.
Does that make sense? Significant event. Okay? So that can help us determine that stuff. All right, I've talked too long.
No, you're good.
We'll wait and do example 4 tomorrow because I think the bell's going to ring anyway. Thank you for letting me talk so long. You could, if you wanted to, do like 1 and 2 and some of those. I don't know. Okay. All right.
I like how the
That's fine.
next example is called a devil.
A devil of a problem. Yeah, we only have 2 examples left.
Use it.
What?
I need some help.
Okay, goodbye.
You want me